Okay, I'll just start off with a simple 1-minute introduction. I think all of you, most of you would know what is a printed circuit board, right? Any one of you, is this your first time seeing this printed circuit board? Don't be afraid. I'm not gonna judge you or anything. Just let me know lah. I'll spend the time explaining. No Okay. Simply put, the reason why we want to do printed circuit board is we want to replace all the jumper wires. We want to eliminate all the wires running on your board. So usually, if let's say this is the first time that you design a circuit, you want to test it. Of course, the first step would be soldering everything on a prototyping board. I think you have seen this online before. There are two kinds of board. Either prototyping board, where in this prototyping board, you can see that all the copper pad here, they are not connected to one another. So you can simply connect it as you like using wires. However, there's also another version, we call it a strip board. I think you have seen this before where every row, they are all connected, right? So this one, we only use this when this is the first time we're assembling a circuit. We want to test it on the board to see whether it works or not. Of course, before that, you should have tried your circuit on a breadboard. So if you rank the security of your connection, I mean the tightness of your connection, of course the worst would be a breadboard. Then the next one would be your prototyping board. And then the one with the most secure connection, of course, is a printed circuit board. Okay, for printed circuit board, one thing about this is, instead of having wires, all the connections are made using copper traces. Of course, here you cannot see the actual color of the traces because they cover the whole thing with a solder mask. You have to insulate everything. But more or less, you can see the lines here. Those lines here are simply your copper traces. Of course, later on, if we have time, I'll give you a walkthrough. I'll let you watch some YouTube video on how printed circuit boards are made. So that you can actually, why do you need to know this? Okay, even though the manufacturing of printed circuit board is simply very chemical side, but then as electrical and electronic engineer, we also need to know so that when we design our board, we know what are the limitations of our manufacturer. Okay, simply put, printed circuit board are made with a piece of copper. The copper plate is fully filled with copper, and then which part that you don't need copper on it, they'll use chemical to remove it. And this process is called etching. So you begin with a full piece of copper, then you use chemical to remove any patterns that you don't want. So this is how it's made. Okay, without further ado, let us start with the hands-on here. Okay, if this is the first time you open KiCad, KiCad would then prompt you for many different settings. Just follow the default one. Okay. Okay, so while you are doing it, make sure that everyone has this schematic with you. I'm going to open this. Okay, make sure you have this piece of paper on your desk so that you can refer it. Okay, today we're going to just design a very simple circuit like this. If this is not your this is not your first time using this software, I believe most of you would have been able to finish it within 30 minutes at most, okay? So usually for experienced user, you may only take a minute or two, but then we'll take the process here very slowly. Yeah. Okay. So when you are designing a printed circuit board, there are basically two major steps you need to know. One is called schematic design. Schematic is anything that you see the symbol on this piece of paper right now. Okay, so schematic tells you everything about the electrical connection of every component. However, it does not actually show you the physical appearance of everything. So everything so far here is simply very theoretical. So this is the first stage, and then the second stage is what we call a layout design. Layout is simply how everything would look like when you arrange them on the board. So this is in the virtual world schematic, and layout is in the real world. So what you need to do to complete a full design is simply these two stages. Okay, just as a heads up here, if you work in the semiconductor industry, of course there will be specialists in schematic or specialists in layout, because for schematic, what you need to take note of the most is mathematical operations. Okay, all the calculations, all the theory. So those who specialize in layout, those who specialize in schematic must be very strong in their theory, because they are supposed to come up with all the device rating, all the components rating, to make sure that your circuit will work. However, even though this whole circuit, let's say I complete with all the specification, it may work on paper, but then once you assemble it, you know already, in real life, nothing is perfect. If I say I want a 1 kilo ohm resistor here, when I actually build it, it's not actually 1 kilo ohm. There will be some errors. So to account for this error, to make sure that even with this error, your device can still work within a range, that's why we need a specialist in layout. Because in layout, even though we assume that the circuit will look like this, but when you assemble them, there may be some parasitic interactions between each component. For example, if you align two copper trays closely together, you have two conductor and one insulator in between. This forms a parasitic capacitance, something invisible. You don't put it there, but then there's an effect there. Okay, so all this need to be accounted by layout engineers. Okay, but then without further ado, of course, I will not try to overload you with too much information. Let's start with the basic first. So the goal for this morning is simply to assemble this circuit, to draw out exactly the same circuit on your KiCad. Of course, right now you have skipped one very important step. The first step, of course, is to actually imagine what is the circuit you want to create. But now we've already created the circuit for you. You just need to replicate this. Okay? But just take note, schematic design is not as simple as what you are doing this morning. This morning, we are fast forwarding. We just let you draw out the same thing. But then as schematic engineers, you need to actually design all this whole thing from scratch. I will just tell you my intended output. Okay? So for those who have seen this circuit before, this circuit is called a first order low pass active filter. Mainly, this works by filtering out all the high frequency signal. So simply put, this can be used in an audio system. For example, like our human hearing range is between 20 Hz to 20 kHz, right? So anything, for example, any frequency that is above 20 kHz, we may regard it as a noise. So all this noise can be filtered out using this circuit. But then when we design this circuit, of course, the client only tells you, I want to filter out high frequency noise. So as engineers, you are supposed to think of this circuit. So this one is spoon-fed to you today. Okay, so with this in mind, let's start drawing. Okay, when you open KiCad, the first thing you need to do is simply create a new project. So if you click on Files here, you can click on New Project. Again, I will not stop to ask you whether you're okay or not. You just simply follow through. You stop me if you cannot follow. Alright, so here I've created a folder for it. If you do not have any folder on your desktop, feel free to create a folder to contain all your projects. So I'm going to click on my folder here. By default, KiCad creates also a subfolder for your project. But usually I like to compile all the folders together. Okay, so let's name it an active filter. Maybe, okay, I will name it slightly longer, low pass active filter. Okay, let's just name it this way. Alright, so right now I have a new project already. So the first step, you can simply follow the sequence of all the icons here. Of course, the first step is schematic. So you just click on the first logo here, schematic editor. Okay, so this is a sheet of paper here. If you have seen this format before, I think you have most likely seen this in a electrical and mechanical consultancy company, right? They usually use this kind of canvas to draw their drawings. Very much similar here. Okay, right now I want you to do one thing. Do not try to use shortcut to create the symbol. Even though KiCad has some installed symbol for you, some ready template already. For example, things like capacitor, inductor, resistor, and so on. But I don't want you to use them. I want you to create them from scratch. Okay, one thing about some of the symbol used in KiCad, they may not be the most standardized symbol that you see in your syllabus here. Okay, for example, in KiCad, the way they draw resistor is not the zigzag shape. They draw it a box. But then in E&E, we call a box a impedance, right? It can be either resistive, RL, or RC, or three of them, all right? So here we are not going to use any shortcut method. Okay, so first, with a blank sheet, of course, the usual rule when we draw a circuit, of course, we begin with 1 point, 1 node by node. Okay, so let's begin from left to right. You can begin from right to left anywhere you want. So let's start from here. Okay, we have a node called Vin. Let's start from Vin here. Okay, what is Vin in this circuit? Let's say, usually any voltage source would have 2 terminals. But then in this circuit, we only give you a node for Vin, right? So by default, you should have the common sense to know that the other node should be connected to ground, referred to ground, okay? So if let's say I give you a context, if this is an audio filter, by right Vin should be something like your microphone, a piezoelectric sensor, okay? So piezoelectric, simply for your information, converts vibration into electricity. So you may be speaking to your microphone on Vin side, then your piezoelectric converts the vibration of your sound into electricity, which is seen as a signal in Vin. Okay? So first of all, Vin does not have a symbol. So in KiCad, we need to create a symbol for it, because if you don't create a symbol for it, you don't have anything physical to connect your Vin, right? So by default, we have to create something for it. Usually Vin, we can simply draw a, let's say, an independent voltage source, right? Usually that's what you do, okay? So Vin here, I will usually use an AC signal because sound is oscillating. So let's start drawing something. So what you can see here is you have a series of icons on the top here. Make sure you hover over this symbol editor. This is where you'll be creating a symbol for every component, okay? Okay, so right now I'm going to be nagging a lot because there are some features that you need to take note of to make your life very much easier. Okay, so before you begin, how KiCad saves your symbol? First of all, you need to select a library. What is a library? Library is simply like a category. For example, if you scroll down here, let's say I click on the analog library, there will be several symbols inside. Okay, so before you create a symbol, make sure you either choose an existing library or you create your own. Since today we are doing it for fun here, let's create a library just for our project. But don't worry, this library, even though you save all the symbols today in this library, you can still use it in the future, okay? So what you need to do here, you click on File, click on New Library. Okay, so here it lets you choose whether you want a global or project library. Project library simply means that you can only view this library in this project itself. But doesn't make sense, right? Since you're gonna use something, create something that is future-proof, just click global. Okay, so just make sure if you want to export this library at the end of the workshop, KiCad save your library in the documents. So make sure you can find this folder there. Okay, later on I'll teach you about the directory. Okay, so let's name this library. In this case, since we are creating some components that are for general use, maybe we can just type general components. Yeah, because all these components are not only reserved for our application today. So general components, and save it. Yeah, of course, if you don't like this naming, you can rename them later. So I'm gonna teach you how to edit your library. Okay, so you click on, let me see here. There will be some component called manage library. Let me find it first. Let's see. see. Manage library. Okay, if you click on the Preference tab, you can find something called Manage Symbol Libraries. So this is where you can actually delete any libraries you don't want or make them invisible to you. Okay, so here if let's say I don't like the naming of this, yeah, I can simply change the naming here. Okay, for example, I want to put underscore instead of using a space. And then if I want to delete, I can also do it here. Remove my library. You can even import library. For example, if right now you want to copy this library into your other computer, yeah, you can also use add existing library to table. Then you can simply find the library you want. Okay. So here I'm gonna click OK to apply the changes to the naming. Okay, so if you run all these features for the first time when you start your PC, there will be some delay here. Yeah, it will take some time to load. Okay, so if I double click on my general components or I use the pen down menu, I don't see anything. But if you want to create any symbol under this library, make sure you have this library highlighted. Then you click New Symbol. Okay, so here I'm gonna name my symbol. So this symbol name is for your convenience of finding this, to reuse this in the future. So first of all, we're gonna create, let's say, in this case, since I mentioned to you VIN, I want it to be like an AC signal, right? So I'll just call it AC underscore signal. Okay, we are not going to derive from existing symbol here. So here, default reference designator. This designator, I believe most of you have used it unconsciously in your unit already. For example, usually we name the symbol of our voltage as V, right? V1, V2, VA, VB. So this V is the designator. And then usually we call resistance R. And then if you use any transistor, we give it a symbol of Q, right? Q1, Q2, QA, QB. There will be a standard rule for this. Usually, you can feel free to use any letter you like actually. But then, the reason why we use this is to standardize engineers all around the world. When anyone see your schematic, they will understand, okay? So let's name this V. And then everything else we put default. Okay. Right now, we have created a symbol. And then this symbol, of course, only has the reference letter V here. So first of all, I'm going to teach you one thing. This will make your life much easier when you design a PCB. Do you see the axis here? Vertical and x-axis. Okay, this axis, where it crosses is simply your origin here. So as a practice, I like to design my symbol around the origin so that later on when I place my things, okay, because KiCad uses a grid system. Everything is placed and snapped to your grid. So if you don't design it, if you try to use a different scale or don't put it at the origin, your life will be very hard later on. You need to adjust your position a lot. Okay, so here, let's see. I'm gonna place. Okay, so right now I'm gonna start drawing my symbol starting from the origin. So before we start, I'll need you to edit one thing. You go to Preference and then click on Preferences. Okay, if it's asking you for anything, you just use the default settings. Just click OK. Okay, so next, let's see here. Symbol editor. Do you see this row here, symbol editor? I want you to click on grids here. Grids is simply like a resolution. Like if you hover your mouse and place something, what is the fineness of your grid? If let's say I say the grid is 1 millimeter times 1 millimeter. Whenever you move your mouse, you can only place components at 1 millimeter apart. There will be dots. If you see, let's say, it go out first. If I zoom in, okay, I don't think you can zoom in here. But then, if I move my mouse, you can see my crosshair. If I move up, My crosshair move at a fixed range, correct? So these are the grids that I have. But then this grid is quite large for me. I'm not comfortable working with this grid. So you can make it much smaller. So one rule here is, if you make your symbol with this kind of grid, make sure you be consistent. In your schematic, you also follow the same grid. It will make your life easier. Of course, you can try to mix and match your grid, but then I've tried it before. My life is very difficult. Yeah, sometimes my mouse, I try to connect something, the mouse cannot aim properly. Okay, so I'm gonna choose as small as I can. So in the real world, if you try to place, if you buy a prototyping board, usually there'll be copper pads side by side with one another, right? The distance between them is usually 2.54 millimeter, sorry, 2.54 millimeter, if I'm not wrong. Yes, this is what we call the pitch, P-I-T-C-H. Pitch means the distance between each pad. So this is a standard throughout the world. And then we're gonna choose the smaller, even a smaller scale, 0.254, okay? But then, of course, one thing about this is, in schematic, all this doesn't matter, distance doesn't matter, yeah? Because schematic is just a theory. Okay, so here I'm gonna maintain everything, okay? So I'm gonna simply click everything, okay? Including graphic. So graphic would then apply, okay, let me see. Graphics grid overrides, okay. In this case, I want all my things to use back the same grid here, 0.254. So I'm gonna unclick everything here to make sure they don't override my settings. Okay, then I'm gonna click OK. And if you see here, my grid has become much smaller. Yeah. All right, so let me check back again. Okay, I'm not gonna use the fast grid switching here. Just make sure this is clicked here. All right, so let's start drawing. Now that I know that this was supposed to be my origin, so let's start drawing here. Okay, I'm gonna start drawing by including a pin first. Okay, so we start with the positive terminal. So the pin name here is not necessary, not compulsory actually. Pin number is also not compulsory, but then if you're gonna convert all this schematic into a layout later, pin number must be put in, because the numbering is simply how layout relates to your schematic later. So pin number, we just put a 1 here. Pin name, you can leave it empty, or I can name it, for example, positive terminal, put a plus here. And then all the things below. Electrical type. Okay, electrical type only matters if you are using KiCad to simulate your circuit. But then KiCad, as far as I know, you only use it to draw. You don't use it to simulate electrical behavior, because we have more powerful software for it. So here, doesn't matter if you don't want to change it. So I can just maintain it as input, but then usually you think of it, some components, when you use the pin, you may use it differently, right? Sometimes Vin can behave like an input. Sometimes you can use it as an output. So doesn't matter I'll just maintain it like this okay? And then orientation, okay? You can simply look at here Don't worry about the right, left, up, down. Just look at where the dot is. The dot is simply where you'll be connecting your copper trace. So I'm gonna just align it this way, okay? So I'm gonna put this circle just right in my origin, so that later on I can connect it very easily. Okay, so right now you can see there's a lot of wording. There are some wordings that overlap one another. Don't worry about the input wording. This input wording is not displayed when you put in your schematic later. Even though it's displayed, but then I don't think it matters here okay? If you think that some of the wording, for example here, the plus sign, is simply getting in your way, you can move that later on Let me see here. Can I move this? Okay, this one cannot move but later on, if you input some text, you can move it Okay, by the way, if you want to hover around, you can use your right click, and then you can hover around here. Okay, or you can use your scroll button. You press it. Okay. Okay, now we have created one end of the pin. The next thing is to create a independent voltage source. So I'm going to draw a circle. You can see that there is a series of shapes here. You can click whichever shape you want. So here I'm going to draw a circle. So the circle, anywhere you place is actually the center of the circle. Okay, so right now I simply draw a shape here. I'm going to move it to match it like this. But it doesn't matter if your circle is not perfect. Don't worry about it. Okay, so right now I have this symbol right now. Okay, right now you can see that if I give the pin a name, I put a positive here, I cannot move the plus around, right? And then this plus actually does not match with the circle here. So in fact, what I can do here is, you can somewhat, what I do here, remove the naming so that I don't see the plus here. But then now I know pin 1 by default is my positive terminal. So I can simply draw my plus later on. Okay, but then one thing, okay, let me correct this. If I call this an AC signal, there's no plus minus, right? It's oscillating. So I simply don't put a plus, okay? I'll be drawing a curve shape. So the curve shape is up to you to draw. Just draw anything that resembles an AC signal. Don't have to be perfect. So I'm gonna click on the arc here. Simply draw, mix and match here as you like. Yeah, draw something a bit like this, okay? You can simply adjust it later on. Okay, this one, let me redraw it. Okay, you can draw something like this. As long as the shape somewhat is recognizable, it's fine already, okay? Don't be too hard on yourself. Don't aim for perfection in this kind of drawing. You can just adjust later on. If let's say afterwards, if you insert the symbol, you are not happy with the symbol, you can simply go back and adjust it and apply the changes. Yes? You just follow. Later on, if you have any question, you can ask me. Okay? Okay, now we're done with this. Let's create our second pin. Okay, we're gonna create a pin that points downwards. Yeah, in fact, it's called up here. Yeah, don't worry about that. And then make sure you name the pin number. I've named it pin number 2. Okay, so far can? So this will be our V in. Okay, so right now, what next? The next part is to save it. Click on the save button. So now we have a symbol already. Okay, so I'll ask you not to close this window. This window, you can just minimize it. And go back to your schematic here. I want you to press the add button. Of course, you can go and find the button that corresponds to add component, but then you just press A on your keyboard. Pressing A on your keyboard lets you add all the existing symbols that you have in your library. Okay? Alright, just now we named our symbol AC signal, right? You can just type in the filter here, AC underscore signal. You can see that our library appears here with AC signal. Okay, and then just take note for your quality of life, they do let you place repeated copies, meaning that if I have this checkbox tick, I can simply go out here. I can simply place one symbol after another, repeated symbol. Okay, this is just a convenience for you. But here, I'm not going to place so many symbols, so I just need one. Okay, so I'm going to go back to this. If let's say you're done selecting, you can simply click OK. Okay. So right now, I'm done with this. We have this, which is our V in. Okay, so later on, I'll let you create the rest of the symbol at your own time. But now I'm going to introduce you with some other features now. Okay, when you place a symbol, if you double click on the symbol here, okay, by the way, if let's say right now I'm done clicking my symbol, I don't want to insert anymore, you can simply use escape button to go back to your default selection. Okay. Okay, now you double click on your symbol here. Your symbol here, of course, the reference they give you is V1. If you don't like this, I can name it as VIN also can. Okay, this is just a naming here. Okay, and then for the value, it's not necessary actually, because you know that our AC signal can be of any value depending on our user input. So there is no designated value for this. So you can simply remain it like this. Okay. Okay, so the next feature I'm going to introduce you to is called a pin, a global pin. If you look at your schematic here, of course, I can simply connect my VIN to a resistor this way and the other end to a ground. But if I want to keep, let's say, I want to keep my schematic as simple as this. I don't want my VIN symbol to appear together with this schematic. What should I do? Okay, what I can do here is, I can simply drag my symbol to the side here. I connect it to a global pin first. Later on, I can connect this same global pin to any component I want. Okay, I'll teach you later on. You understand what I mean as you do it. Okay, so right now, if you hover your symbol here, all the icons here, you can see something called a place global label. This is what we call a global label or global pin. Okay, this pin, the name is very important. Okay, so we're gonna name this pin VIN. So this VIN is just like a global node. So you can rotate it if you press Ctrl R, or not Ctrl R, you just press the letter R. Place the R key, you can simply rotate this. So right now, I place my pin here. You can see that this box here, if you move your mouse over here, you can connect something to it, right? Okay, if you click on this, you are already drawing a wire. Okay? So right now, before we start with anything, I want you to edit something first. Of course, you click on Preference, go to Preferences. Now you're on the Schematic Editor side. Okay, I want you to select Grid. Make sure your grid is of the same scale to make your life easy. So I'm going to select the smaller scale here and click OK. Okay, right now I'm going to align my symbol properly according to the grid I want. Okay, you can see that previously I used a different grid and now my symbol is out of place, right? So how do I realign them? Actually, you don't have to delete this and create again. You can just right click on this. You can see that there's a button called Align Items to Grid. So this item is aligned already. So let's go to the next one. This one also aligned to grid. You can see that everything aligns properly now. Okay, right now I'm gonna connect them. So how do you know that you're actually clicking on the pin on the connection point? If you hover over here, you can see that your mouse changes the shape. Yeah, this means that you're on the right track already. Okay, and then for this part here, I'm not able to connect them properly. You can see that this is the tough part about grid alignment. The way I place my symbol here, I cannot reach it, right? In fact, if you click on this, does not form a connection. It keeps prompting you to connect again. So this is the part where things can get a bit annoying. So in this case, what you can do here, if you find that this is a problem with your symbol, no matter how you align it, you cannot connect them properly, you can simply go back to your symbol editor. You click on this to reopen your window, or you can click back here. Go back to your symbol editor and then realign your symbol again, meaning adjust the position a bit. So here, let me just drag it down a bit. Let's see if this helps or not, okay? So right now, I'm gonna click Save. Okay, so here what you can do, you can update your symbol. If let's say you already placed it, you can choose not to delete and create again. You can simply update this symbol so that everything on your symbol will update properly according to what you have changed just now. So you can update everything here. I think all the default selection has been chosen for you. Don't need to do anything else. I think just click update. Let's see if this changes the position or not. Should be. Okay, still doesn't align properly. Let's see. Let me align it. Let's see whether I can connect or not. Okay, so not. So I just delete it first. Let me see. Input again. Okay, apparently you can see that the way I place my cursor, this is the origin. So actually, my symbol here is actually out of the origin. So what I can do, I go back to my symbol editor. Let me adjust this. I think the symbol should be moved up a bit. So move it upwards here to the origin. I think the origin should be in my V here. Let's see. Can I set my origin? I think there's a feature here that allows me to set my origin. Place origin, draw text. Let's see. Read here, no. Okay, hold on. Let me just move everything first. See whether I can move this or not. Okay, so right now apparently I made a bit of mistake here. If you see that initially your symbol is created with a designator, the designator here you can see a crosshair here. This is actually your origin. So actually if I want to align everything properly, by right I should put my pin directly at the origin. Okay? Don't worry about the V overlapping with your symbol. You can adjust the position in the schematic. So I'm gonna save it again. And let's go back here. Okay, we add this symbol. Okay, right now you can see that I fixed the problem. Now the pin is actually aligned to my origin here. So if I place this, I think I can connect my component properly. Yes, now it works already. Okay. So you can see that the process of doing this, even for experienced user, you can also make a lot of mistakes, but then you can simply troubleshoot your way out. Of course, this skill, of course, is very much transferable to other software. Yeah, so do not worry whether you may do it on the first try or not, as long as you troubleshoot it. Okay, so right now I'm gonna proceed with some other features. Then we're gonna make this session free and easy. I'm gonna walk around and then make sure that you can create everything, you can draw everything. Okay, so right now I'm gonna go ahead to another tips here. Let's say I created a global pin VIN. What does this mean? If I call this a global pin, meaning that if I create another pin, okay, and I name it exactly the same name, this means that this is literally the same point as this. Understand or not? Okay, so if let's say I do not want my V1, or instead I call it VIN, I do not want this AC signal to cram with all my other components. I can put it at the side, connect this point to VIN, then I simply rotate this. Okay, now from this point on, I can start connecting this point to my R1. Okay, so right now let's start creating our next symbol, R1. So let's click on General Components again, and then create a new symbol. So symbol name, we call it a resistor. And then reference designator, R, and then click OK. So right now here, again take note, when you create R, the crosshair here is the origin. So if I want to create my symbol properly, I'm gonna draw the pin, First of all, pin name, R does not have a pin name, right? Register is simply a passive component. So I just give it a pin number 1. And then electrical type, actually, if you want to be sure, to be strict with it, the electrical type should be passive for register. But if you don't change it, doesn't matter. We are not doing any electrical simulation here, okay? Orientation, I will align my circle to the left-hand side. We call it a right here. So where do I place this point here? This connection point, I place it at the origin, which was shown just now. So if I click on R, let me just move this out of the way. If I click on R, the origin is here. Okay? So make sure you memorize this point and you move it here. Okay? So this is my first pin. And next, I'm gonna start drawing my resistor. Any zigzag shape you want, doesn't matter, don't have to be perfect. So I'm gonna simply draw it. As long as it looks good to me, then it's fine already. Okay, if you are a perfectionist, you may draw it with the same angle, okay, but for me, it doesn't matter. Okay, simply click until you are finished drawing the lines. So right now, I want to terminate my lines here, but then you can see the software is still prompting me to click on it, right? What you do now, you right click and then click finish. Or you can use the end button, END, end button on your PC, okay? By clicking this, you are ending the connection. You're ending the drawing here. Okay, let's draw the pin. One last pin to draw. We call it pin number 2. And then I'm gonna align the connection point the other way. Okay, so this just looks just like a resistor. Alright, so I'm gonna save it. Okay, you guys okay? Okay, I'm gonna pause here a bit. I'm gonna walk around if you need any help. Alright, so while we're waiting, meanwhile, anyone has any questions about what we have done just now? You want me to repeat everything? You can say your word. Are you fine to proceed? Okay. Anyone problem? Okay, what you're doing, I'm gonna show you, for those who have computer, I'm gonna show you some tips here. Okay, I'm gonna demonstrate to you how to use a global pin. Okay, so right now I've created a register. So let's say, on this schematic, there are two ways that I can connect my register. Either I input now, okay, let me just input my register. Okay. There are two ways I can do it. Either I remove the global pin, I connect my register directly to my V in here. So I'm gonna realign. Let me realign my R1 to the grid. Okay. Either I connect it directly here, just like this. This is also count as connecting to V in, right? Okay, the cons of doing this is if you use this kind of habit, your schematic can get messy if you place more and more components. For example, if let's say I want to place my R1 very far ahead, you need to draw your connection all the way from the right side of your canvas all the way to the left. Of course, this does not resemble the actual distance on the layout, but then this creates a lot of nuisance when you are viewing the schematic. So if you want to keep your schematic tidy, what you can do here, follow my steps earlier, maintain the V in. If let's say my R1, I decide not to draw anywhere close by my V in. I want to draw it over here. What do? I create the global pin that has exactly the same naming, V in. So if I create this global pin and I connect my R1 to this node here. So let me align it to grid. If I connect it like this, connecting R1 to V in is simply the same as connecting to this point. So meaning that if I create two V in here and I connect R1 and V in to this same pin name exactly, I'm simply connecting R1 and V in together. Do you understand what I'm saying? Okay, so this naming is important. If you name it the same name, this means that these two global pin is exactly the same node. Alright? Okay, so right now, let's give R1 just a random value. Of course, we're not designing for any specification. So your value here, let's say I give it 10 kilo ohm. Okay, of course, we cannot insert any symbol, we cannot type in any symbol in this KiCad. So we just name our ohm as HM. Okay, let's say 10 kilo ohm. So this is our R1. Alright, I'm going to show you how to use this. Okay, so we have done how to use a global pin V in. Alright, so by default, KiCad here, right now we have not inserted any ground yet, but KiCad here has a global pin for ground already created for you. So if you type GND, you can see that GND has a symbol created for you already. So by default, KiCad understands this as a global pin for ground. So it's not the same appearance as what you see in a circuit. Okay. So if let's say you don't like this symbol, what do? Okay. I can maintain this. Let me see. I think, okay, let's not make your life difficult. Let's just use this symbol as it is, okay? Let's not create another symbol for it. Okay, let's just use this ground. Just take note, the shape is not the same as what you are used to. Okay, and here apparently you can see that my line is not aligned properly again. So this means that this part pin 2 of my V in, I have to adjust the symbol again, okay, to make sure that it aligns properly. So right now, let me go back to my symbol. You can simply click on here. You can edit your symbol here, but I like to edit my symbol globally. So I can click on symbol editor, go back to my AC signal. So let me adjust the size of my symbol here. Adjust everything so that I can align my pin properly. so that it's easier for me to connect. Okay, so this one, let's see if this will help me or not. Okay, I'm going to save it and go back to my schematic. I'm going to right click on this and click update symbol. Right, so the sizing, the positioning of my pin has been adjusted accordingly. Let's see if I can click this properly or not. Okay, still unable to click this properly. So it's off by a bit here. So how do I offset for this? Let's see. If I go back to my symbol editor, if I move this slightly a bit down, and then this circle, I make it slightly a bit bigger here. Okay, let's see if this can fix the problem or not. Okay, don't worry about this line here, doesn't matter to me. Okay, let's go back to our schematic. And then I'm gonna update it again. Let's hope this time round, okay, this time round I've adjusted the pin position such that it can connect properly. Okay, so this is the, I would say, a bit of annoying part about KiCad. You have to make sure that your symbol is aligned properly, otherwise you have a hard time connecting. Okay, but then if you fix this issue once, the next time you can simply reuse this symbol easily. Okay. Alright, so far I think more or less I've taught you any features that you need to complete this schematic at least. So I'm gonna continue to walk, and then you can look at how I do it, and you can ask me if you have any question. And afterwards, I'm gonna teach you some more advanced features. So right now, I want you to complete the remaining of this circuit. So once you have created the symbol for R1, you can reuse this symbol for R2 and R3, meaning that you can either go back to your instances to create the symbol, or you can simply copy paste, okay, R2 and R3. Okay, so for this one, just make everything 10 kilo ohm. Okay, now I'm gonna go ahead and create the remaining two symbols that we have not created before. If you have done so, yeah, feel free to connect everything. Okay, if you need some revision, you can look back at how I do it. Make sure that you don't miss out any single step. Some of you, I noticed that if you miss out any important step, yeah, you may have some symbol that, for example, wrong designator or wrong origin and so on. So I'm gonna create my capacitor. Okay, give it a C. Alright, so this is my origin here. So let's place my pin accordingly. So I'm gonna call pin number 1. Not give it a name. Okay, now I place it here, and then seems that I need to rotate it. You can also use R to rotate. Yeah, same thing. So right now this is at my origin already. Okay, now I'm gonna draw my capacitor. Okay, so for our capacitor here, we're drawing something without a polarity. So this is a tantalum capacitor. Yeah, you can draw an electrolytic version. Electrolytic version meaning that one side is a curved shape, correct? So here I'm done drawing the capacitor. Let's place my other pin here, pin number 2. Okay, I'm gonna rotate it. So hopefully this pin, they are all aligned properly. So I'm gonna save it first. I'm gonna give it a try. So R1 connect to C1 this way. So I'm gonna insert my C1 here, capacitor. Okay, so let's hope this aligns properly. Okay, apparently now you can see that my resistor is slightly misaligned. So I'll need to go back to my symbol here to actually edit it. So let's go back. I'm gonna edit by slightly, just a bit. I'm gonna move it just a bit here, okay? And then fill this with a line. Then edit. And then save it. Okay, so what next? If let's say you have multiple resistors here, okay, what I like to do is you can just Control A and right click and then let's see. Okay, of course, okay, there are multiple symbols here, never mind. Let's see if I can update everything here. No. Okay, let's see. Update symbol. There should be a button for me to update everything. Apparently no, never mind. So this one I have to do it manually here, update symbol. This one also, same thing, update symbol. Okay. Let's see if I can do multiple click. Okay, I think can. Let me see. Update symbol from library. Okay, as long as I select all the symbol here. Yeah, you can use update symbol from library. You can update everything together. Just that the only limitation is you cannot have the wires and also the global pin selected. But here I want to give you some tips. You take note that on the left bottom corner, there is a selection filter. Selection filter simply means that what your mouse can click on. If let's say, I only want to click on symbol, I don't want to accidentally, let's say, for example, I don't like my circuit here. I don't like how I connect, but I want to maintain my symbol. I don't want to remove it. I just want to delete all the wires. What should I do? You untick all items, you just click on wires. Meaning that whenever I click on my schematic here, I can only select anything that is wire. You can see that no matter how I highlight, I can only highlight the wire. So here what you can do, if you want a shortcut, you can click on symbol only. I highlight everything and then I click update symbol from library. With this, I can actually update everything one go. Okay. So once I'm done, okay, I can actually go back and click on all items. Okay, I believe this feature, you can find this in any other software that allow you to adjust what things you can click and what things you cannot. This allow you to edit everything very quickly. Okay, right now let's see. Yes, my capacitor can now connect properly to my R1. Alright, and then for capacitor, let's give it a random value. Okay, so I'll give it, let's say 10 microfarad. Okay, and the other end of the capacitor is my ground here. You can see that. So what I do here, I just copy paste this ground global pin. Okay, make sure one thing, the naming of this has to be the same, ground. If you name it as GND1, I believe KiCad understands it as a new ground reference. It's not the same point anymore, right? Okay. So right now I have this. And now the next step here, I need to create an op-amp. So this part here, you can simply reuse the skill that I have taught you. I'm going to create an op-amp here. So I'm going to create a new symbol. Symbol name, I name it as op-amp. And then for an op-amp, since this is made of transistors, so I will name it a reference designator of Q. Okay. Otherwise, okay, usually you can also name it U, because U also can be used for IC, integrated circuit. So op-amp is actually, of course, op-amp is made out of many transistors. So actually, to be strictly speaking, op-amp is count as an integrated circuit of transistor. So actually, I should name it as U, okay? You can click on the reference and then change it to U. Okay, now this is my origin here. So I'll make sure one of the pin is actually at the origin. Okay, later on, as you see, may need to edit the location of the pin accordingly. Alright, so for this part here, op-amp here, I'll need to wait for a while. Wait until everyone is ready, because this part here, I will need to introduce you with some additional knowledge. So for now, at least I would say, for now, make sure everyone has actually completed up to at least here, R1 connected to Vin. Anyone has not done this yet? Okay, you wait for later. I'll continue with the rest first. Alright, so let's start creating the symbol for our op-amp. Okay, one thing about op-amp is, if you look at our symbol here, we only have 3 pins, right? But in actual fact, the usable pin that we usually, I would say the functional pin, we actually have an additional 2 more pins. One is the V plus, positive rail. One is V minus. Okay, I'll try not to confuse you with the symbol. Okay, by right, I don't call it V plus, V minus. I call it VDD and VSS. So the higher voltage supply and the lower voltage supply, VDD, VSS. By right, this is the V plus, this is V minus. V plus here is the non-inverting input. V minus is inverting input. Okay? And then here, of course, is the V out, V naught. Okay, so technically speaking, there are 5 functional pins. But then op-amp here, usually based on the design structure that they make, if you see any IC packaging, you have seen IC with 8 pins, right? 16 pins, right? Yeah, of course there are 5 pins IC, but then they don't look the same as what you see here. Okay, let me see. I'll just open it here. 8 pin DIP IC. I think more or less you all are familiar with this kind of IC, right? This IC, 8 pin IC. So the IC that we're using today is packaged according to this standard. Alright, so before you can actually design a symbol for op-amp, just one thing to take note, some manufacturer, they name their pin number differently from one another. So one thing, the first thing to know is how to read a data sheet. Sometimes you can simply design the schematic, only then you search for the data sheet. But sometimes this has to happen concurrently. So right now, we are going to use this component here. You can type LM741. This is a National Instruments op-amp. Okay. So LM741 datasheet. One thing about this, for those who are going to do your final year project, you can find this component readily available. National Instrument is a brand that is widely sold by many different suppliers. But then one thing about this is, many suppliers, usually if they provide you with a component, they will attach their datasheet on their website. But here's the part about National Instrument. The original datasheet would not be available on the supplier website. You have to go back to the National Instrument website. Don't know why, but maybe it's their copyright issue, not sure. Okay, you can have this datasheet downloaded. Okay, so right now I'm going to teach you how do you read this, how do you use it to design your schematic. So once you download it, let's open this. I'm going to draw on it. You can see it as usual. When drawing schematic, usually we only draw the 5 functional pins. So where are the rest 3? By right, if you want to create a schematic followed by a layout, you have to include all 8 pins in your schematic. This is for you to do theoretical design. But then to make it into reality, you cannot exclude any other pins. So right now, I need you to scroll down here. You can see that this is actually the actual hardware layout. There are 2 kinds of packaging, but we're using this kind of packaging today. Okay? And sometimes, some manufacturers, they give you the convenience. They mark the pin number directly on the first page. But for National Instruments, sometimes you need to scroll down until you see here. Okay, you may need to refer back and forth. But for your convenience, I'm going to draw my symbol here. So this is my V plus, this is my V minus. Of course, some of you may invert the plus and minus. You can draw it the other way around, doesn't matter. Okay, so this is my V out. And top here is my VDD. And then here is my VSS. Okay, so I'm gonna now assign a numbering to each pin. So if you look at this packaging, V plus, where is it? It's pin 7. So I'm gonna name it 7 here. V minus, pin number 4. Okay, remember this is very important. If you give the wrong pin number later on, as you build your layout, everything would not be synchronized. Okay? And then VDD. Where is it? Okay, my bad here. By right, let me see. The way they name. Okay, this can be a bit confusing. That's why sometimes you need to have a look here. Okay, right now, without prior knowledge, I assume V plus and V minus as my input. But then if you look closely, there is inverting input and non-inverting input, right? By right, this is my V minus. This is my V plus. Okay, so that's the first mistake I made. Now I double check it, I find out that this is wrong. Okay, I need to correct this. Meaning that the numbering that I assigned initially, this one has to be corrected. The V plus that I've used for my design, I name this as non-inverting input. So by right, this should correspond to pin number 3. So this is number 3. And then V minus here is my inverting input. So this one is pin number 2. So I have it here. So what is the V plus and V minus that I see just now? If you like to use your standardized naming, the V plus in National Instruments is actually your VDD. V minus is the VSS. The positive rail of your power supply and negative rail of your power supply. Okay, different manufacturer, they name it differently, so you have to be careful. But one uniform thing is they will usually tell you which one is the input, which one is the output. Okay? So have to be careful here. Usually make sure you go back and double check here. So in this case, of course, it may not be obvious. They name the V plus V minus at the power supply rail. But they don't give a name, they don't write any name at your input here. So sometimes this can be a bit misleading. Okay, but with some experience, you start to notice, okay, start to find the differences here. So the VDD here actually is the pin number 7. So after correction, this is the correct pin. VSS is pin number 4. Okay, and then we have V out. V out here is the output, is pin number 6. Alright, now we have only accounted for a total of 5 pins. We have 3 more to go. So where do we draw the rest of the 3? The rest of the 3, up to you where you want to draw it, as long as it does not overlap with the existing 5 functional pins. So let's start with the first one, offset now. Okay, these 2 are the pins that are connected to where? If you want to know, you can scroll down here. So this is the actual internal circuit of the whole IC. You can see that you have all the pin number labeled for you. So pin 1 and pin 5 offset now. There are 2 different points but with the same name. So this one you need to be careful. Okay. So these 2 pins here, I need to assign them separately. They are not the same point. So I have pin 1 and pin 5. Okay, later on, I just remember to name them as offset now. And then I have one more pin here, pin 8. What is NC? NC stands for not connected. So why do they create a pin that is not connected? Because this is simply a standardized packaging. Whether you use add pin or not, the add pin is there already. Okay, so what is the use of this if let's say it's not connected? Usually they use the non-connected pin as a way to distribute heat. Simply, you still need to solder this pin here. Number 8 pin still need to be soldered somewhere to your circuit, but then it acts as a heat dissipator. Okay. You can read all the description here. Everything is here already. Alright, so pin number 8, since I've run out of space, I can put it here. Okay, 8 is NC. So with this kind of diagram, I'm gonna start drawing my symbol. Okay. Alright, so for beginner, you might make mistake along the way, but then it's okay. It's okay to make mistake as long as you troubleshoot it later on. You know what is wrong with it, okay? So right now, I'm gonna start here, create my first pin. Okay, I'm gonna start from left to right. Let's create the non-inverting input, V+. So I'm gonna name my pin number pin 3. And then since this kind of setup, this symbol is unique to National Instruments brand. So I have to give it a pin name so that I don't get confused in the future. Because all other M symbol in the future, they will look the same as this, but then their pin name and pin numbering will be different. Okay, so I'm gonna name this pin name. Instead of naming as V+, okay, V+ is usually what you learn in theory. We use V+ and V- to indicate the input. So here, maybe I'm gonna use back the same name as the National Instruments. Okay, I'm gonna use some short form here. Non-inverting. N-O-N-I-N-V, okay? Non-inverting input. So let's name it this way. Okay, I'm gonna align my pin directly at the origin. Okay, here for my convenience, I'm gonna copy paste this. I'm gonna rename it. So I'm gonna change this to pin number 2, inverting input. Okay, by right, these two pins should be input type, but doesn't matter here, we don't care about this. So let's forget about this. Alright, so we have one side ready. Okay, now I'm gonna proceed with drawing the triangle first. Okay, the triangle shape, don't have to be too strict about it, as long as it looks like a triangle enough. Okay, I'm gonna draw it slightly bigger. Okay, let me align this properly here. Okay, don't have to be too perfect. I know my triangle here is not equivalent triangle, doesn't matter. Alright, I'm gonna proceed with the remaining pins here. Do it one by one. I'm gonna do my output pin first. Usually what I like to do is I settle the input and output followed by power supply. So I'm gonna go to pin number 6. So pin number 6, I name it as output. And then I'm gonna flip the pin to the other side. Alright, doesn't matter if this line is not aligned properly. We can fix it later if you want. Okay, just make it like this. Alright, I have already accounted for 2 inputs and 1 output. Now I'm gonna settle the power rail. So the next one, I will use a slightly different naming because V+ and V- here can be a bit confusing for some users. So I'm gonna name this as VDD. VDD will stand for the positive rail of any ICs. So the pin number here, I'm gonna give it number 7. Alright, so here I'm gonna rotate it. Okay, you can see that all these names, they are overlapping with one another. I would not mind about that. What I will do usually, I will double click on the pin to check for the name. I will double check using this way. Okay. Okay, I'm going to create the next pin. Pin number 4, VSS. Okay. VSS. Pin number 4. Maybe I'll use a capital letter S here. Okay, doesn't matter. Let me just create one more time. VSS. Pin number 4. Okay. Okay, I'm going to rotate it and put here. Alright, so later on, if I fail to connect anything to this pin, I need to realign them. Yeah, that's for sure. Okay, so right now I'm left with the remaining 3 pins. So I have 2 offset pins. So right now, I'm not going to name this as full. I'm not going to use offset now. I'm going to name this as offset. So here, I have pin 1 and pin 5. But usually, to segregate between pin 1 and pin 5, maybe I will look at this diagram here. So pin 1 belongs to the non-inverting side. And pin 2, pin 5 here belongs to the inverting side. So maybe here I will just give a slightly different naming here. Okay, so right now I'm gonna put in my pin 1, and then maybe I'll call it offset. Offset, put a bracket plus, okay, the non-inverting side. Okay, maybe not a space bar here. Just put like this. Okay, then next I'm gonna put pin 5. I'll just copy and paste, and then I'm gonna change the pin number to 5. Put offset minus. Okay, so the plus and minus is some additional naming I add into the naming so that I can differentiate between these two positions. Okay, you can see that the pins, they are not aligned on the same level. If you are the type who like to align them the same way, yeah, feel free to drag them down and then draw some physical lines here. For example, like this. Maybe I can draw a straight line connecting from here to here. Yeah, then I can make sure that everything is leveled. So this is up to your choice. And then if I want, I can also drag this towards the top. And then I'm gonna draw a line here to connect it. Alright. And then lastly, I have pin number 8, which is not connected. So I'm gonna make it full screen now. Okay, I'll name the pin name as NC, not connected, pin number 8. Alright, so there you have it. Yeah, if you need to use this symbol in your project, yeah, you might have created one already. Yeah, you can simply reuse this in the future. Yes, now that I've dragged my pin slightly away from my symbol, you can see the naming doesn't quite overlap with one another. Yeah, if you want, you can also drag all this further away. For example, I want my output to be seen visibly here. I can drag it out and then draw a line. Okay, this is not aligned properly. You can do this. Of course, this symbol is not perfect. You still need to do some adjustment. So I'm gonna spend the next few moments to adjust it. So I'm gonna save it first. Go back to my schematic. Yep, now we have already done the hardest part of this schematic. So I'm gonna make the remaining 30 minutes free and easy. You simply try to do anything you can. And then before we go for the afternoon time, which is layout. But for now, let me just finish everything for this schematic here. So this op amp, I'm gonna place it here. Okay, just to make sure that I'm doing the correct connection, because this is an active filter with negative feedback here. So based on my schematic, my V-in should be connected to the non-inverting side. Make sure you have this correctly connected, okay? Output is negative feedback into the inverting input. So make sure all this is correct. So I'm gonna try connecting this. Okay, so this works here. Okay, one thing about this, if you take a look here, if I connect my non-inverting input to this wire here, this creates a connection node, right? So this node here, you can see, there will be a circle here. This represents that you are connecting everything properly. Make sure you are seeing this, okay? Alright, so I'm gonna start moving the remaining of my components here. Okay, I'll align my R2 and R3 correctly according to this orientation so that I won't confuse you later. So I V out connected to R2 and then R3 gives the feedback. So I'm gonna put it here. So R2 is here. So R3, I'm gonna rotate it. Okay. So R3 goes to ground. Okay, now I have one problem now. You see that my output pin here, my crosshair doesn't quite reach it. I cannot create a wire from it. You can see that my cursor does not change shape even though I hover over here, meaning that this output pin is quite misaligned. So I'll need to go back to my symbol and edit it. Maybe I'll edit it, move it by just one grid here. Okay, one grid towards the left. Let's see if I can fix the problem. I'm gonna update the symbol. Okay, the problem is still persistent. So I'll need to... Okay, you can see that if I try to draw any wires, it would be slightly above or slightly below and one grid to the left hand side. So here I'm gonna move my output here, 1, 2, 3, okay. So I'm gonna do it 1, 2, 3, 3 grids towards downwards, and then I'm gonna drag it 1 grid towards the left. So this would be the new position of my output. Then for my shape, I may need to adjust it accordingly. And then you can see that now I have a lot of things overlapping. I cannot select them properly. So you can use the selection filter. I can untick everything. I can simply tick on graphics only. So that now my pin, I cannot move them. I can only edit the drawing. With this, I can easily navigate around. Okay. So I'm gonna change my triangle this way. And then maybe these two lines, extend it a bit. I may need to change this later on. Okay. Okay, now I've saved it. And let's get back to our schematic. Update my symbol again. Okay, now I can connect it properly already. Output can be connected. So here. Alright, and then feedback, I connect it to my inverting input. Here, okay. So I can adjust the position here. Okay, so for those who are not used to non-inverting input and inverting, you can simply put a plus sign. Non-inverting input refers to the plus side of your input. Okay, if you are beginner to this, you are not used to looking at this naming, what I can suggest you is, okay, let me enable the selection filter for everything. You can put a plus here. Non-inverting input refers to plus side. Inverting input refers to the negative side of my input. Okay. Then I'm going to save it and apply the same changes here. Update symbol. Okay, I'm going to move everything downwards so I can space here. Alright, now I am left with VDD and VSS. Okay, so what do we do here? VDD and VSS, they are not drawn in our schematic. VDD and VSS are decided by the user. So for our case here, I'm gonna set the benchmark for my positive and negative rail. Let's say I want my positive rail to be positive 5 volt. I want my negative power rail to be negative 5. So how do I go about that? Okay, I know that sometimes in electronic units, in circuits, what you are used to doing is you are used to doing this. You simply draw a bus with 5 volt, right? And then over here, you would draw a bus with -5. But voltage supply in the real world doesn't work this way. We have 2 terminals for each voltage supply. But how do I maintain this convention for my easier reference while making it, I would say, making it technically feasible, okay? How do I make it feasible while making my life easier when viewing the schematic? Very easy, make use of global pins. So what I can do here, I can create a DC power supply, okay? So right now, I'm gonna draw out a template first. I'm gonna create a DC power supply. Let's say I call this a VDD. This would be my global pin. I'm gonna connect a 5 volt to my VDD with the same template, just like my AC signal. Can, right? So right now, I'm gonna create another symbol that I have not created before. Okay, so right now here, how do I quickly create another voltage supply without spending much more effort? Very easy. You can simply right click on AC signal. You can duplicate this symbol. By duplicating, you're creating the exact same symbol with the correct alignment. You just need to rename it. For example, I can name it as DC voltage. And then I simply change the drawings here. So you can insert your plus and minus sign using text like this, or you can even use lines to draw it. It's up to you. Okay? So just like that, I've created an AC, I've converted from AC voltage to DC voltage using this simple feature. Okay? So I have now DC voltage here. So I'm going to create here, insert this symbol, DC voltage. Okay, I'm going to insert it anyway, and hopefully everything aligns. Yes. Now everything aligns properly. Okay. Now I'm going to do one thing. I will duplicate this VDD. This global pin will be connected to the VDD pin of my op-amp. So this here, this VDD here is simply the same meaning as creating a bus here. But how do I make sure I assign a 5 volt? Very easy. You click on this, okay. The reference name, you can give it V1, or can also give it a same name, VDD, maybe small letter here. Okay, the value I put 5 volt. And there I have it. I'm having a DC supply of 5 volt connected to VDD. Alright, and then I set VSS. I want -5. So how do I do it the shortcut way? I'll show you here. Copy paste this part here. Change this to VSS. And then change the naming here to VSS as well. But however, since I want -5, I should revert the connection. Reverse it. Meaning that this voltage source introduces a 5 volt difference. Since my ground is now the positive side, 0. Ground is 0 volt. This means that this node here is 0 minus 5, -5. Understand, right? This one pretty straightforward. So I'm gonna put my global pin here. Alright, so you can see that now I have created a new problem here. My pin 4 is actually not properly aligned. So I'll need to align it again. So to make sure that I align it just one shot, I'll need to start drawing lines from my VSS first. I can check. It seems that my wire can only be drawn this way. Okay, so there's one thing here. One thing weird about this part is you can notice my mouse can hover over a very small resolution, but my wire seems to have very large resolution, right? In fact, there's also one workaround. Since you know that this is still technically on grid, so how do I make it? In fact, there's one setting that we have not done yet. If you go back to preference, you go to grid, wire has overridden. It has overridden your grid setting, so make sure you untick everything. I think if you untick everything, this will solve the problem. Now if I start drawing wire, you can see that my wire have very small resolution already. Yeah, now everything becomes very simple. So I can start dragging this, okay? So one mistake I made beforehand, actually this can be fixed without changing your symbol also, as long as you do this. Go back to preference, make sure that nothing gets overridden. Do not override your grid. Just simply default everything to the same grid, okay? Alright, so right now we have all this connected. You can see all the functional pins are connected already. Right now, okay, for our usage here, since our component does not have any error yet, so by right, we don't know whether we need the offset or not, but we may need it in the future. So these two offset, pin 1 and pin 5, should be connected to something, like an open pad for us to solder in the future. So by right here, I'm gonna create a symbol just to symbolize a pad. Okay, so what I'm doing here is maybe I will create a symbol here. You can give it any name, just an unknown symbol, maybe just call it a pad. Just a pad symbol, single pad, okay? And then the reference designator, I don't think there's a specific name to it. Let me search for it. Electronic reference designator. Let's see whether we have a name for any pad or not. Okay, pin header. Maybe this counts as a pin header. Let's give it a J. So let's give it a name. J here. And then this pad here, maybe since it's just a single connection point, I'll just give it a pin just like this. Okay, just like this. Enough already. And then give it a pin number 1. And that's it. Just leave it hanging like that. Okay? By right, it's not hanging because this is the only connection point that you have. So I just save it. Okay, then I'm gonna go back to my schematics here. So I'm gonna add a pad here. Let's see, single pad. Alright, so I'm gonna rotate it. Connect it first. Wait, I think I seem to be pressing a button that locks my rotation. Wait, hold on, let me see. Can't seem to rotate it. Click on the symbol here. Okay. Let me just put it over here. Okay, I think you will have a hard time selecting this symbol and then moving it. So what you can do, again, selection filter, enable symbol only. Then you can freely drag this around, okay? So for this one, there's no value to it, but I can use the value to name it. Maybe I'll just name it as an open pad, okay? Just a pad for me to use in the future if I need to calibrate this recalibrate this op amp or not. Okay. Then I'm gonna create the same thing here. Let's select symbol. I'm gonna paste this. Okay. Alright, so I have pin 1 and pin 5 connected to an open pad. And then perhaps in the future also, I may need additional ground pad so that if I want to use pin 1 and pin 5, let's say using a voltage supply to correct the offset, I can connect the other side negative terminal to an open ground pad. So here I'm gonna do some extra feature here. I'm gonna give a ground, then I'll create 2 more open pads. Okay, I'm gonna rotate this. Okay, this one I'll put at the side here. Okay. Alright, so if you have problem clicking on this, I also can suggest a solution to you. Since this is like a pad, why not we just draw a square shape like this? Yeah, this is just like a block terminal. So if you draw a shape like this, I think it will be easier for you to actually select this in the future. Alright, and then it will make much more sense on your schematic. So I'm gonna save this. Go back to my schematic here. Okay, I only select all the symbol. I will just Control A and then update symbol. Okay, now I have it. I have all the open pads here. And then pin 8, not connected, I can just leave it here. Okay, afterwards, maybe if you do any electrical check, maybe KiCad will tell you there's an error with one of the pin. But then this one you can ignore because I left it open intentionally. Okay, I leave it open intentionally. Okay. Alright, so with this actually, I've completed the schematic. So you can have a look here. So your task for the remaining time of this morning is simply to replicate the same thing as what I've done. Okay. For my drawing here, it's very detailed. So if you think you cannot handle such detail, feel free to create something as bare bone as this one. Okay. Because right now, the important point is to get you used to the thought process of designing a schematic. There's no right answer for today's session, okay? We are not going to test you on anything. So just make sure that you know how the system works, how the software works. Once you get more understanding in the future, yeah, you can get the whole circuit right. Yeah, for those who are trying to revise this, just to let you know here, the RC circuit here is the low pass filter. When your signal comes in, the RC here actually filters out all the high frequency signal. Only the low frequency voltage is inputted at your V out here, at your V in, V in positive, your non-inverting input. Okay, so this part is in charge of the filtering. And then what about R2, R3? R2, R3 is in charge of magnifying the volume, meaning that it can magnify the output voltage magnitude. Okay, so if you look at this from a speaker perspective, R2 and R3 controls the volume, how much volume is amplified according with respect to your input. And then R1 and C1 here is in charge of your sound quality. Okay, so in general, you can look at it this way. In an audio system, what affects the quality of your sound? It is the frequency component of your sound. If you get rid of all the high frequency noises, your sound quality becomes better. And then getting a high volume doesn't mean high quality. Volume, as you know, is simply the amplitude of vibration, how loud you hear something, all right? So perhaps this may be new to you, yeah? R2, R3 is in charge of volume. R1, R1 and C1 is in charge of the quality. Yeah, by the word active simply means that your output can have a higher or equal magnitude to your input. It will not be lower. Some of you who have just undergone circuits in electronic, you have a simple RC circuit, but that is a passive filter. Passive simply means that your output would not be greater than Vin. At most, at the best case scenario, it will be equal to Vin, but then it would never, okay? Of course, some magnitude will be lost. Alright, so with this, okay, I'll stop for this one in the morning, for the morning session. Okay, I will just walk around, I'll stop the recording now.